Hello everyone, and welcome to week 4 of ExCode. This week's session is going to be a bit shorter than usual, since last week's was a bit longer and some quite intense subjects were introduced. So I'll just get right into it and share my screen. Okay. Right, okay, so quickly just go for a recap, and then we'll go over dictionaries, and then we'll go over some sorting algorithms, and just finish off with some questions at the end. So for the recap, what we did last time was if and else statements. So I'll start this off by just getting a variable. So that's variable 1, give it a value of 15. So how an if statement works is basically you have a conditional and you test if that conditional is true. And if it's true, you run the if statement. If not, you run the else statement. So let's say run this if test variable 1 is larger than 15, then we'll run this and we'll say larger than 15. So if we run this, hopefully I've written it correctly. So I'm basically just testing if this is larger than 15, which it is, which it isn't, sorry, because it's not larger than it's not. So let's just put that as 16 quickly. So it tests if this statement here is true, and in this case it is, because 16 is larger than 15, so it runs this code, and let's put it back to 15 in case 15 isn't larger than 15, so it runs the else code, which is here. Okay, next, while loops. So I think we just introduced them with counters. So if I have a counter and I assign it a value of 0, I'm going to go through a while loop. So a while loop just continues the loop and runs everything inside it until the statement at the top is false. So if I do while counter is smaller than 15, and while it's doing that, I'll just print out the value of counter. So what it's doing here is it's saying while counter is less than 15, continue this loop, and I will, each time I have the loop, I'll increase counter by 1. So basically what this is going to do is going to run this 14 or 15 times. Let's do that. There you go. So simply what it's doing is it is just saying while counter is less than 15, run all this code, and every time I run the code, I'm increasing counter by 15. So once counter hits 15, it will no longer run this loop, and it'll just continue the program. And then a break statement. So a break statement is used when you have a while loop or a for loop and you hit a condition. So then you're like, okay, I don't want to continue the loop anymore. And then it just breaks you out of the loop right there and then. So I've got counter already. Don't even need that. So while, so I'll do while true. This basically is sets the while loop to true. So it runs infinitely because obviously while loops run while something is true, and if I set it as true, it's going to run infinitely because it's always going to be true. So we want to break out of it somehow. So let's say when counter once again gets to 15, so every time we'll do counter equals counter plus 1. So every time we do the loop, we're increasing counter by 1. And then if counter is larger than 15, then do this. So every time we go through the loop, we're increasing counter by 1. And then when counter is larger than 15, we will break, and we will say print is larger than 15. If we run this, so basically what we're doing is we're just looping through until counter gets to 15. Then this if statement finally becomes true once counter is 15 or larger than 15. And then it runs this and it says to break break the while loop, and then continues from your program, just whatever you've written beneath it. So it's simply the same as doing a normal while loop, except instead of sort of checking here, you're checking elsewhere and then quitting the loop there. Okay, so we're going to look at dictionaries. So dictionaries are a lot like lists, except they come in pairs. So they come in a much like a dictionary. It's like your word and then your definition of the word. But in this case, it's a key, so a unique key. So it can't be more than one of it in a dictionary, and it's paired with like a value. So it's just a list of pairs, one of which is a key and another is a value. Okay, so Nick wrote these slides for me this week. So thank him for all the GIFs and things. One of the reasons you want to use dictionaries more than lists is that their speed is like a lot better when you're sort of searching for things. So I'll quickly just show you how you make them. So let's make I think the example was given is like if you have a car and you can sort of create a dictionary of like all the attributes of the car, like its brand, its model, or the year it was made. So in this case, a dictionary called this dictionary, and it's going to refer to everything about this car. So let's talk about, let's give it a brand. So the brand of the car is going to be a Ford. What we've done here is we've given it a key. Sorry, I need a drink of water. Right, so you've got a brand. Oh, yeah, sorry, a brand, and then that's the key. So you're saying, I've got a brand, and then you give that brand a value. So in this case, it's Ford. So whenever we search through this dictionary, we're going to search for brand. And when we search for it, we'll get the result of like Ford back. So it's storing two types of data. So the syntax for this is just the key, a colon, and then the value that you're connecting to that key. And then if you want to add more, you just use a comma. And another, you just continue it. So if I were to use model and then colon and Mustang. So what I've done here is I've created another key, model, and then I've assigned it a value of Mustang. So just like a dictionary, a real life dictionary is just the word and then the definition in a sense, but they're called keys and values. And then it's also put down the year and then put down 1964. So as you can see, this is an integer, whereas the other ones are strings. So you can use, once again, different types of variables for keys and their respective values. So I've got three things in this dictionary. I've got the brand, the model, and the year, and their respective attributes. If I were to print this out, you can print this out exactly like you'd print out a dictionary or anything else, where you just print and then this dict. So once again, you can see it just prints out once again like a list, where it's the key, the value, then the key, value, the key, and the value. So next you can just access it, much like the sort of same way you do in a list again. You have to use, when you're accessing things, you have to use the key value, the key name, not the value. Sort of the way that dictionaries are structured, you search via the key and you get the value from there. You don't really want to search via the value. It's sort of not what they're built for. That's one of the reasons they're so good with working through things really quickly, is because of the key sort of value relationship. So if I were to do this dict, and then I wanted to search for the key of model, so I wanted to find the model name. So in this case, I've been Mustang. So I've done x equals this dict, and then much like in lists, use the square brackets, but this time instead of using like the index of where it is in the list, it's actually just the key name. So in this case, model. And if I were to print x out, which I'd assigned the value associated to model to, it should come back as Mustang. So yeah, so basically what I've done is I've just said dictionary, find the key model and get the value that's associated like associated with it back, and then put that into X, and then just printed X out. And much like lists, once again, you can just edit all values that are inside the dictionary, and you once again have to use instead of using the index in the dictionary, you use its key. So I could set the year to 2020, and then if I print this dictionary out, it should have changed the year from the original 1964 to 2020. So carrying on the theme of it being much like a list, you can loop through these dictionaries to get the values as well as the actual keys. So, so all the key names. So let's do for X in this dictionary. You can just print X. It comes off this time, but it comes off with all the keys as opposed to the values. So the brand, the model, and the year. You can also print all the values in the dictionary as well with that. So for X in this dictionary, you can do print this dictionary X. So in this sense, what we're doing, we're just looping through the dictionary and we're getting every single key. So in this case, we're getting brand, then model, then year, and we're printing out this dictionary and then the key. So just like we're doing here, we're printing out this dictionary, brand, and the word associated with it will be the first one. And then we'll go to the second one, which is model, and it will print out the ones associated with model, which is Mustang. And yeah, so it should loop through all of them. So you're just accessing it in the exact same way you would a normal list, except you're not using indexes to get each value, you're getting the key associated with it. Okay, now you also can straight away just get the values from a list when you loop through it. So you could do for X in values. So this will give the exact same result as before, except we don't have to do the sort of little part here. Instead, when we loop through it, we're getting every single value in the list as opposed to the key. Yes, so there's that. Whereas in this one, we were just getting the key and then accessing it through through using the square brackets. This time, we're just straight away getting the values by using dot values at the end of dictionary. Now loop through both keys and values. Okay, so you can also get both the key and the value at the same time. So for write this down, explain it. Okay, so much like how we use dot values to get the values straight away in from the dictionary instead of the keys, we can use dot items. So what I've done here is usually it's when you do a for loop, we do like for X in, and then every time we loop through, X will stand for something, or we could use like for values in or for Y in. It doesn't matter, it's just a representation of it. Here we have two things that we want to represent. We want to represent the key and we want to represent the value associated with it. So we do that by doing for X, Y in this dictionary dot items. So we're saying for the pair X and Y, which is the key value pair in this dictionary, loop through all of them. So then we do that and we say the little extension at the end is dot items after the dictionary name. And then from there onwards in that loop, X and Y will represent the X primarily being the key and then Y being its associated value. So that from then onwards, each loop will be using X and Y as the key and the value. Now you can check if a key exists. So Much like we can compare anything, we can if something's bigger than, or if something's less than or equal to, we can it will give back true or false. We can also check if something is actually in the dictionary. So so for instance, check if model was present in the dictionary. So if model in dictionary print it's in there. And that it's in there. So basically what it's doing is it's if something with the key model is in this dictionary, then run this. So it basically just looks through the all the keys that are in the dictionary, and then if it's in there, it says, okay, yes, it's in there, so run this. So for instance, if I were to spell it wrong and put down models, nothing would run at all, because there's no such thing as model in there, but there is something that's called model in there. So it runs that. Now, you want to get a dictionary length as well. So that's quite important. This is also extends to not strings, it does it to strings, to lists as well. So you can find the length of a list and a dictionary simply by doing the word length and then the dictionary name. So I'll assign that to y equals, and then if I print out y, it should come out 3, because that was the length of our dictionary of 3 items, 3 pairs of keys and values. So yeah, it's just length and then open brackets and then put the list name or the dictionary name or the string name, and it will return how long that list, string or dictionary is. You can also add items to a dictionary. So obviously, like a dictionary, it can only have one, like a unique key. So much like a normal dictionary, you can only have have one word, and then it has associated definitions or multiple definitions, but the key has to be unique. So for instance, what should I do for this? And a mileage. So if I were to do this dictionary, so just like you would to add something to sort of like overwrite something in a list, you can do that. You can add stuff to a dictionary as well. You simply just use this dictionary and then put down the key that you want to add in and then its associated value, and it will add that to the dictionary. So another thing you have to notice is that, as I said, everything is unique. So basically, if there's something in there already called mileage, it will overwrite the already placed mileage. So I print it there and I do the exact same thing again, but this time I change it to 700. So the first time I print it, up here it's 600, and then I try to change the mileage. It finds mileage in there and then changes it. So it's unique. I can't have more than one mileage in a dictionary. The key must be unique. So overwriting, you have to be careful of it. And that's one of the ways for checking if something is in there. So for instance, if I didn't know that the mileage the stat was stored in there, but if it was stored in there, I don't want to overwrite it for some reason. I could use the if something's in it. So if I were to if mileage in this dictionary, I run this now. Sorry. Yeah. So we can run something called like use the word not. So if mileage is not in this dictionary, then run this. So it's the keyword not in, or in this case, just the word not. So what it's saying is if mileage is not in this dictionary, then run this. But mileage is in this dictionary, so it's not running this. This is just sort of a quick check, just in case something's already stored in your dictionary, but you don't want to overwrite it if it is. So it's simply if there's something with the key mileage and it's in there, don't run this. Only run this if it's not in there. So that's one of the uses of the in. It's just you're using the opposite, using not in. Now, so the del keyword removes the item with the specified key name. So it's just like the list again. You just do del and then this dictionary and then the name. So in this case, I'll do mileage. I'll delete mileage from it, and I'll then print out this dictionary to see the change. So as you can see here, above there was mileage in there, but now that there's, sorry, no, I've run it twice. Sorry, I've run that code twice, so it's deleted it from there. Don't worry about that. So basically, you just use the del keyword followed by the name of the key, and then it will delete it from the dictionary. But you have to be careful, because if you don't, for some reason, you don't actually, you forget to actually put like the description on here. Like for instance, if you forgot to put the key and you just use the name of the dictionary, it will actually delete the whole dictionary as opposed to just the single individual key value combination. So if I run this is just, don't have to worry about this, but if I try to, so I've deleted it here by accident using del, and I forgot to use the square brackets and which value I want to delete, it will completely delete it. And if I try to use it later in the program here, when I try to print it out, it won't be able to find it because you've completely deleted it off the system. Okay, right, now you also have the clear method will empty the dictionary. So if I just do, what have I done? Let's just create this again. Let's create another one. I can just do this clear, and it will clear the dictionary, much like deleting it. Next is copying dictionaries. This is a bit more difficult. So in like previous examples, we've shown that you can use variables to make other variables. So for instance, if I had a equals 1 and b equals 2, then you could like c equals a, and then it would assign the value of a to c, or c equals b, and it would assign the value of c to b. Unfortunately, it doesn't really work like that if you're trying to copy a list, sorry, not a list, a dictionary from like one part to another. So say I have a dictionary of values, and turns out I've got the car and I've got another car that I'm like, oh, I can just copy all the values from here because they're exactly the same. It doesn't really work like that with dictionaries. What ends up happening is if I were to just use this dictionary again, I'll use this dictionary 2, and I will say I want to actually just copy all that data, and I'll go this dictionary 3 equals this dictionary 2. Okay. Now if I print that out, it probably looks absolutely fine. So I'll do this print and then this dictionary 3. So I've just copied dictionary 2 to dictionary 3. Now this might seem absolutely fine. Obviously everything seems absolutely in order, but the issue is I've not actually completely copied dictionary 2 to dictionary 3. What I've done is I've sort of referenced dictionary 3 and dictionary 2 in this case. So if I were to actually just go this dictionary 2, so I'm referring to the original dictionary that I've tried to copy, and I do brand, and I set the brand to, let's just do, I don't know, McLaren. And now I run this, and I make sure I print that below. The brand name's changed here, even though I've been trying to, I've referred to dictionary 2 and I've changed something in dictionary 2. Even though I've copied dictionary 2 to dictionary 3 beforehand, so I've just copied 2 to 3, and then I've changed dictionary 2's brand. Although I've changed dictionary 2's brand, it actually shows that it's changed in dictionary 3 when I print it out. So simply what's happening is when I try to copy dictionary 2 to dictionary 3, I'm not actually copying it over. I'm just saying, okay, don't copy dictionary 3 over, just look at dictionary 2. So whenever I refer to dictionary 3, it's just going back to dictionary 2 and referring to it. You're just referencing the dictionary. So any changes that I make in dictionary 2 will show in dictionary 3 because they're not separate. All I'm doing is saying, I can't be bothered to copy it, just look at dictionary 2. And they're basically the same entity, they've just got different names. But you actually sometimes really want to just copy them properly. So I'll make dictionary 4. So let's do dictionary 4 equals this dictionary 2 dot copy. And I'll print that out here. It's dictionary 4. Okay, so as you can see, dictionary 3 has changed when I changed dictionary 2, but dictionary 4 hasn't changed. It's remained at 0. So what this adding dot copy makes a hard copy. It completely makes 100% new dictionary and copies and pastes it into dictionary 4. Whereas dictionary 3, when you just assign it like you would any other variable, it just references the other dictionary. It just says, this is the dictionary that you want to refer to, but we're not going to copy anything. We're just going to point towards it. It's basically just pointing and saying, whatever we do here is actually over there. You're not actually making a hard copy of it. You're just pointing to it. Okay. And yeah, if you're really keen, I'm just going to give you a quick show of all the things you can do with the dictionary. Much like length or delete, there are dozens of sort of different commands that you can do with the dictionary. But then, you know, you're probably never going to use them. I don't think I've used all of these, but there's loads of different things you can do with the dictionary. There's little commands like .items, .copy, or delete, or keys, or values, etc. Okay, so that's just dictionaries for today. Now we're going to go on to a quick look at like an algorithm that's a sorting algorithm. So when you, like, for instance, if you were on like your like a file explorer, you're just looking through your files, looking for your documents, looking for your like coursework and stuff, you can sort of order things based on preference, like the file size, the name, how many files are in each file, and you can sort of just sort them all out. And they use algorithms for this. There's a really, like, the most simple sort of sorting algorithm that they think they teach at ComSci or at Decision Maths, maybe at like A-level or GCSE, is something called a bubble sort. And it's sort of, it's a way of sorting numbers by their values. So I'll quickly sort of explain how this works, and I'll quickly just like build a small program using for, if, and lists, just to show that it's everything you've done can be used in sort of a way that's like applicable to everyday use. So the way a bubble sort works, so let's say we start with a list of the numbers 5, 1, 4, 2, and 8, and we want to sort them so that it's going in ascending order. So we'll have 1 here, then 2 here, then 4 here, then 5 here, then 8 here. So sort it just going up. Now we can obviously just sort it quite easily ourselves, but a computer needs like a step-by-step guide to do this. And the way like a really simple way of doing it is something called a bubble sort. And the way this works is you sort of compare two numbers, and if one's bigger than the other, you swap it, and you completely keep doing this. And I'll just sort of, until you've got like an ordered list. So I'll quickly explain how this works. So the first way you do this is you compare 5 and 1. So I'm comparing 5 and 1, and what I'm doing is I'm checking which one's larger, and whichever one's larger goes right. So in this case, 5 is bigger than 1, so 5 swaps with 1, and then you compare the next two numbers, 5 and 4. So you then compare these two numbers, and then 5 is bigger than 4, so you swap, and then you go over to the next two numbers, 5 is bigger than 2, so you swap, and then you go over to compare the next two numbers, 5 and 8, and 5 is not larger than 8, so they don't swap, and 8 remains there. You start this all again once you get back to the beginning. So I go back to the beginning and I look at 1 to 4. 1 is not smaller than 4, so they don't swap. 4 is larger than 2, so they swap. You go to the next pair and it's 4 is smaller than 5, so they don't swap. You go back to the beginning again. I say 1 and 2. 1 is not larger than 2, so they don't swap. 2 is not larger than 4, so they don't swap. Then that one's in place, and then you finally do the last pair, 1 and 2. 1 is not larger than 2, so they don't swap. And then you've got the remaining one now in order. So simply put, what it does, this algorithm, it sort of just, it compares two in pairs, working its way up until it sorts the whole list. And I'll quickly just show you how this works in Python. So we've got a list of values in no order whatsoever, but we want to order them. First thing we want is to find the length of this list. So I'll do length of list equals length my bubble, just how, like it worked with dictionaries. You can find the length of the list. So length, I'll just print this out just to show that it's worked. 24. Okay, now as like my as the sort of as the steps showed, what we're doing is we're simply comparing the first two, the second two, the third two, and the fourth two, and we're sort of just swapping them if the first number is bigger than the second number, and if it's not, then we just leave it the same. So basically going through every single number and just doing that until you reach the end. So we're going to use for loops for this. So if I were to use I'm going to use X and Y for my for loops, just to make it easier. So for X in range, and then 1, I'll quickly explain what this means. Okay, so we came across this when you can use in range with for loops. I think it was last session, where you just basically, it goes just like in a for loop. You have to imagine it's a for loop that is from 0 to whatever's in the range here. So I'm basically, in this case, this is 24 long. So what it does is it goes through a for loop, but it's as if it's going through a list from 0 to 23. In this case, it'll be 0 to 22 because I've got -1. So if we're looking at what this means in terms of the algorithm, it just means that I'm looking at this pair, looking at I'm sort of going through each number once and just comparing the pairs. Okay, and then we also need to realize that every time we compare a number, we're not just we're comparing a 1 to those two together, those two together, those two together, and we do that all the way along, and then we do it all the way along again with the next numbers, and then all the way again with the next numbers. So we're just completely just comparing. So we then need to use another for loop, because for every number we're comparing it to every other number. So we will do another for loop inside that for loop. So well, I understand this is probably quite difficult, and I'm not really expecting anyone to fully understand this, but I'm just showing a rough idea of how some algorithms work. So for y in, now we're going to do range again, and we'll do for y in range x length -1. I'll quickly explain this in a second. So in this example here, when we look through it, once we've compared something, we've put it in its right place, we don't need to compare it to anything else because it's already in its right place. So for instance, when we go through 5, we don't bother comparing the 5 to the 8 because we've already compared it the first time we went through. We know that 8 is right in its rightful place, so we don't compare it. So this is what's happening here, is that we don't compare. For instance, if we compare on the first loop, we compare everything up to the 34, but then we'll put once we've compared everything, the biggest thing will be at the end. And then when we compare things again, the next biggest thing will be at the end. So we don't need to bother comparing to the end. We need to compare one from the end that we've already sort of compared. So that's why it's minus x, because every single time we loop through, we're increasing it. So we're comparing to 1 less every time we loop through. And then what we need to do is, we said when we compare things, we compare that it's bigger than the one next to it. So we need to do if the value in y, I'll just quickly do this, is larger than . So what this is saying, it's basically saying if the value here is larger than the value here, then we swap them. So, and then I'll just do a quick else here. And otherwise, and if it's not bigger than it, so if in this case like 1 and 3, it won't run this. It would go to the else. If we are sure that something is bigger than it, we swap. So in this case, like we have a 4 and a 2, we check that the one afterwards is bigger than it, and if it is, then we swap it. So we want to sort of mimic that as well for every comparison we do. So the way we do this is we can do all quickly. So the issue with this is that if we want to swap something in a list, we sort of, when we swap something, we sort of delete it. So we want to store it by itself. So the first value, we'll set it as my bubble. Okay, so that's just storing the first value in the pair, and then we'll do the second value in one. That's storing the second value in the pair, like in front of this pair. That's storing the first value and then the second value. And what we want to do is we want to swap their places. So we just do my value plus 1. And we sort of set them to, so the first value, you want to set it to the second value, and you want to set the second value to the first value. Now that should be the whole algorithm. So basically what this is doing, I'll quickly run through it. I'll quickly print off what this has done. I understand this is probably a lot to go through, but I've also at the bottom, I've linked, this is basically the last exercise, just to do this yourselves. I've got the example in there, in my code, but I've also linked a video as well as some more pseudo code, which is sort of like natural code, like as if I'm speaking it to you. So I'll quickly run through how this is all working. So I've got this list and I found the length of the list. Now I'm going to loop through that list 23 times because basically I don't need to do the last comparison, because once I've compared everything, there'll be like one left over in without like something to compare it to. So I'm looping through every single value, and then every single value is then being compared to every other single value. And then if that value and is larger than its pair, so it's the one that after it, it will swap with it. Otherwise, it won't swap with it. So now if I were to print this, everything should now be in order. So that unordered list is now ordered. I understand that's probably quite a lot to process. That's why at the bottom, I've linked a video and I've linked to like sort of an explanation of how to write the code in like in normal English. So I'll go over it one more time quickly, how this all works. Here we are. I'm getting the length of the list and I'm looping through every single one. And I'm comparing it to its neighbor, and then I'm swapping it if it's larger than it. And I do this for every single one. So I compare the first one and then move all the way down and compare it to the remaining 24, so the 23. And then I compare this again, but with 22 as opposed to 23. And then I compare it with 22 because I'm basically ordering they'll slowly get ordered at the end until you reach the end where it's everything will be ordered. Okay, that's probably a lot. Don't expect anyone to really understand that. I just thought I'd put it in because we were only looking at dictionaries today, so I thought I might add something a bit more intense at the end. At the end of this, I have added saying try and build your own, but obviously if you struggle with that because it's quite difficult, just look at what I've done, look at a video, sort of ask your TAs on how to do it. Okay, once again, thank you very much for Nick for writing this one. If you guys would like to split off into your TA groups, that'd be great. Okay, thank you very much.